Hi folks, this section is on galaxies. Now in our textbook, the information on galaxies is actually scattered in a variety of different chapters, and I'm putting all of this together in one lesson. So let's talk about galaxies, which are so fun and so interesting. And the one we're going to start with is talking about our very own galaxy, the Milky Way. Um, the Milky Way refers to this band of gas and dust that we see when we are standing on Earth and we look upward. That actually is our Milky Way, and not everyone has ever seen it because of the fact that we live in a world full of light pollution. If you do see it, it's more likely you're going to see a faint band that looks like this, as opposed to the beautiful dark Milky Way from this photo. So it all depends upon where on planet Earth you are, whether you're going to see it or not. I remember the very first time that I saw it well is we were actually camping up in the Rocky Mountains, and it was very, very far away from everything and very dark. So around our area, lots and lots of light pollution, less chance of seeing it on a normal night. Slightly different names. If you refer to the band of gas and dust that you see when you look up, that's referred to as the Milky Way. And I always think what a charming name because it does sort of look like a puddle of spilled milk somewhere in the sky. If you refer to the entire galaxy, then that is the Milky Way Galaxy. Now, as we talk about galaxies this chapter, I'm going to show you an awful lot of galaxy pictures as we explain things about the Milky Way. Please keep in mind that at this point in history, we have never actually seen the Milky Way from the outside. No probe has ever left our galaxy. No spacecraft has left our galaxy. So the pictures that we show you of what the Milky Way looks like are not the Milky Way. They are another galaxy that we think is very similar to our own. What actually makes up this band that we see up in the sky, this Milky Way? A lot of it is made up of gas and a lot of it is made up of dust. How do astronomers find the difference? Well, gases produce an emission spectrum. An emission spectrum is like this, dark with individual bands of light. Every time one of those little electrons jumps up, falls back down because it has some heat energy, and it emits a very specific photon or wavelength of light. And that's how gases emit light. The dust are the bits that block visible light. And there is a lot of interstellar dust in our galaxy. To try and figure out what that is made of, that's actually going to produce an absorption spectra. An absorption spectra is the opposite of an emission spectra. It takes light from behind it and sucks up or uses the individual wavelengths depending upon the chemical composition of what is actually in that dust. So when astronomers examine the Milky Way or any galaxy, they are going to be looking at both emission and absorption spectra because each are going to tell us slightly different pieces of information. Where are we located in the Milky Way? Well, human beings have always been incredibly egocentric. We like to pretend that we are the center of everything, back from the old days of Aristotle, when it was believed that everything revolved, including the sun, revolved around planet Earth. When we first started looking at the Milky Way galaxy, of course, we assumed that we were at the absolute center and that everything revolved around us. As is quite often in life, we find out that no, things do not revolve totally around us, and the same was true for the Milky Way. The fellow who actually determined our position in the Milky Way was a gentleman in 1917, an American astronomer named Harlow Shapley. Shapley is a very respected astronomer. Did some amazing work a little over 100 years ago. And he started examining the positions of globular clusters. Now, there are two different kinds of star clusters: globular clusters that are these absolutely beautiful structures that look very much like the puffs on the end of a dandelion. Very beautiful, very well organized little creatures. The other type of star clusters are irregular clusters, and irregular clusters, as we've talked about in the past, are exactly what their name indicates. They are not this pretty, beautiful, round structure. So slightly different groups of star clusters. Irregular clusters are young. Globular clusters have a tendency to be very old, looking at the age of the stars. But anyhow, this all goes back to Harlow Shapley. And Shapley was looking at the positions of globular clusters. And what he found was this: if this little yellow dot is an indicator of where we are, and Shapley started studying where the globular clusters were, and he found that they were not centered around us. What he found was that the globular clusters were centered around an area some distance from us. So if we are here next to the sun, the globular clusters are located somewhere over here. Well, what is going to make objects in space gather together? Well, the thing that's going to make them gather together in space is gravity. And so he came to the conclusion that, firstly, we are not the center of the Milky Way, and that the globular clusters were actually gravitationally centered around the center of our Milky Way galaxy. Kind of the analogy is, I like the party analogy. If you're at a party, I don't know about the parties you go to, but there's usually a lot of food involved. And if everybody is clustered over here, that's probably where the food is. People stand around and talk and drink and eat. And that's probably the same analogy. If all the globular clusters are over here, then that's probably where the galactic heart or galactic center is. And it was not around us. Again, this is not a picture of our Milky Way galaxy, but it's a picture of a galaxy similar to ours. And if the heart of, or the center of the galaxy is right here, we are about 2/3 of the way out from the center. So we are on an outside arm of the Milky Way galaxy. So how big is the Milky Way? Well, the Milky Way has a diameter of about 90,000 light years. Now that means if you are on one side of the galaxy and you shone a flashlight from over here, and you turned your flashlight on and then turned it off, 90,000 years later, the light would hit the other side of the galaxy. So that is an incredibly huge object. The radius from the outside, from the center to the outside edge is about 45,000 light years. And the thickness, there is actual thickness to it. And we're going to go into all these structures in more detail in a little bit. But there is a bulge in the center. The galactic bulge has a thickness of about 10 light years. Same thing, if you shone a flashlight beam from one side, it would take about 10 years for light to go to the other side of that bulge. And there are also spiral arms. These spiral arms are very, very thin, pancakey kind of thin. When I say pancake thin, I'm talking about on a astronomical universal level, not as thin as a real pancake. Probably a silly thing to say. There are lots of different parts of the Milky Way galaxy, and this is going to take us a little while to go through all of these different parts. But again, there is a central bulge. There are thin spiral arms, so that if you, depends on how you look at the galaxy. If you look on it edge on, it's going to look like this. If you look on it sideways, it's going to look like that. And again, we are about 25,000 light years from the center. Globular clusters are around that galactic center. Now that central bulge, if you happen to find yourself in a very dark portion of planet Earth and you can see the Milky Way, the central bulge is going to look wider than the rest, and it is going to look a combination that's kind of a wacky combination of brighter, and it is also going to contain a lot more dust, so it will also look thicker. When astronomers look at the stars in the central bulge of our galaxy, it was found that the stars are very, 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 very old. Matter of fact, the oldest stars are in our galaxy are in this central bulge. How old? About 8 billion years old, or some possibly older. We think the entire universe is about 13.7 billion years old. And so this is probably, our galaxy is maybe 2/3 of the age of the entire universe. When we talked about black holes, we referred to the fact that it is believed that at the heart of every galaxy, there is a supermassive black hole. And the supermassive black hole located at the heart of our Milky Way galaxy is Sagittarius A, sometimes abbreviated and said as SAG-A. It doesn't exactly compute with the abbreviation that astronomers use, but humans like abbreviations. But this supermassive black hole in the center of our Milky Way galaxy has a mass of about 4 million suns. Yeah, I'll let that sink in. 4 million suns of our stars. And that, we think, is the mass of that black hole in the center. This happens to be a relatively small supermassive black hole. There are much larger ones out there in much larger galaxies. So we're going to stop here, and I'm going to ask you to watch this really awesome little video where it actually will show you some of the real live movies of stars and that are orbiting the black hole in the center of our Milky Way. For many years, this was hypothesized, and we now have observational proof that this supermassive black hole does exist in the center of the Milky Way. All right, see you soon.